Hello guys, today I'll be discussing about syncing sourcing inputs. This has to do mainly with the wiring of the PLC. That's how you really wire your PLC, your inputs, your digital inputs, usually digital inputs like push buttons, proxy sensors, your limit switches and all that kind of stuff. So as you all know, a PLC module card or a CPU, it comes in this form. This is an input card. Okay, this is an input card. So we're gonna start with syncing inputs. So basically what you do when you're doing syncing inputs, let's say you've got your push button, it comes like this, and then you have another push button, and then you have another, let's say it's a stop, right? If it's a stop button, I'm sure we all understand that conventional current, it flows from positive to negative. So conventional current, it flows in the direction from positive to negative. It flows from positive to negative. So if you're using syncing inputs, so if this module card is a DC sync, we say DC sync, right? So this card is a DC sync. What it means is when you're wiring this thing like this, you have your power supply here. This is our power supply, 24 VDC plus minus. Okay, that's our power supply. So you wire your common like this. Then your common goes to the minus. Okay, that is the negative. This is the negative, the minus there. And then the plus comes like this. So when you're syncing, it's like you have a bucket, okay? And then you are pouring from the source. Let's say you have two buckets. You are pouring from the source, and then you are pouring into another bucket. So this is the source. When you're pouring, like this is a bucket, something like that. So you're pouring outside of the bucket, and then you have another one here. So this one is sourcing. This bucket is sinking. So whatever you're pouring into, it's sinking, it's receiving. That's how it works. So what happens now is with conventional current, our current flows from positive to negative. So your arrows, they face like this. Your arrows are like 1, 2. They are going out of the power supply. They are going out of the power supply into your card. You see, because the power is coming from here, it's going into the card. So this card now, if we go back to our simulation of the sourcing and syncing, it means this PLC is the power supply is like it's sourcing power. But what is syncing? The card is syncing because it's wired this way. The card is the one that is syncing the current. So this card is wired in a sync mode. Okay, this is a DC sync card. Okay, so what we mean here is if your current comes in, it goes into the card and then it goes out like back to the source in negative terminal. That's how you wire a DC sync, a syncing module card. Okay, this is how you wire. I'm not talking about sensors now like PNP, and we're just talking about digital dry contacts, open close. This is how you wire your syncing module card. If it changes to become a sourcing output card, it means what changes mainly is here on the polarity here. I'm gonna do it now. So what I will do here is the common we have to change. If it's now we are going to the sourcing now. So we are done with this. We are now coming to the sourcing input card. Okay. So if this one is sourcing, the direction changes. Sorry. Right. So this one is sourcing now. So the plus goes there. And then this one becomes the minus. This one becomes the minus. So what happens now is your current is going into the card first. When it goes into the card, it goes out of the card like this. When it's going back to the negative. So now, where is the power coming from? The card is the one that is sourcing. It's sourcing the current out of it because it's being powered. The common here is powered, so it's sourcing. It's pushing out of the card. Then it's going back to the current is going back to the power supply. So this is how you wire a sinking input card and a sourcing input card. But what is really happening in your PLC? So it's basically simple. I'm just gonna try to rub half of it so that I can explain better. What we are trying to say is, if you have a card, like I'm gonna make the card a little bit wider. If you have a card like this, what it means is on the common there, let's say we are in this, we're doing the sourcing part. On the common there, on the common, your common is inside the PLC. Okay? Then it's here. It will be wired like this. That is a positive, so it's like this. Okay? Then there's a thing like this here, which is going to your PLC side. This is inside. This is a circuit. This is a circuit that is inside the PLC. So this is a just want to say it's a one thing. Okay. This one I'm confused. Okay, so this is an opto-coupler, an opto-isolator. So this one is gonna go to a screw terminal here, which is X1. So X1 now, X1, when you close the push button, it's going to minus now. It's going to minus. Remember, we're talking of a sourcing card. So this is what is happening inside the PLC. I'm just trying to explain what is happening inside the PLC. So you'll be having an opto-isolator that is like this, okay? And then it has got a plus here. So what it's looking for to switch on this LED is a negative. It's looking for a negative so that it can emit that light, which is going to be received by a phototransistor inside of the PLC. This is the configuration. Every input card, every I/O on the PLC will be having this opto-isolator to protect the PLC from the outside environment, okay? So if there's a short or a spike, it bears this isolator. It doesn't affect your CPU. So what happens now is the source is already there because it's this one. It's coming through our common. This is our common. And then when it comes, it's now waiting for you to press the button. So when you press the button now, this is a negative, right? So your current is trying to flow, is facing this way. So the moment you press the button, this opto-isolator glows. That's when you see on your inputs or the PLC, the light flashes. It glows. When it glows, it sends a light inside the opto-isolator to the phototransistor, and then the phototransistor sends to the PLC brain to say, I have received an input. So this is how it's wired. On the common, you're like, so what's going on the common? What's the difference? So the configuration is like this. And then when it changes to a syncing, what only changes here is the common is the negative now. Is the negative now. So if this one is the negative, it means the configuration of this thing changes, okay? Or what they just do is, okay, it will be like this. Okay, and then our direction is changed of the flow of current is sinking. It's sinking. So the common, this is the common. So with the common terminal is connected to the negative. So this is the positive now. This is the positive now. So the PLC will be sinking because the common is negative. The current is coming through here. So what determines the syncing and the sourcing is what is wired on the common of your input card. If your common is a negative, it means the whole inputs that are coming to the module card is going to be absorbed, the card is going to sync that current. And then if it's a sourcing, it means the card has got a positive on the common is going to be sourcing. So definitely this is how it's wired. I'm sure you understand. If you have a question, you can just ask in the comment section. I can really explain to you if you have any area that you are not understanding. Then you come to other PLCs like a Delta PLC. A Delta PLC has got some of them. It's not really a Delta, but most of them, they say it's up to you, the guy who's doing the drawing, to determine whether you want it to be a syncing or a source. So what they do normally, they tell you this common can take anything, either a sync or a source. It's up to you. You decide what you want. So they usually say SS. You can write it as an SS. This is our input card. Like we said, and then it's written S/S. So it means you can sync or a source with this card. So how do you do this? It's up to you. You decide depending the way you want to wire it. You can, if you want it to be a syncing, then this must be a negative. If you want to be a sourcing, this must be a positive. But what is happening with the opto-isolator, back to what I explained, it means that isolator has got two LEDs inside. So we have a photo transistor this side going to our CPU. Then this side now, you have an LED like this. Then you have, oh, it's a bit too high. Then you have another one. So this is a one opto-isolator for a single input. Okay, so maybe this is for the input IO X0. This is inside the PLC on the PCB board. So when you put we decide, no, I want it to be, this is your common, this is your IO, let's say X0. Okay, so what we are saying now, if it's a sync source, you'll be having two diodes, one facing up, one facing up. Remember, this is inside an opto-isolator. This is inside. So what happens now is that when you are syncing, this one becomes your negative. You are syncing, you get me? You are syncing. So when you are syncing, this one becomes your negative. So you go in, and then this one is one that is conducting. Sending right there. And then when you are now sourcing, this one becomes your positive, and then it means this one is one that is conducting now. Then it's sending the light to the photo transistor. So that's how this terminal can become a sync source, or it can be a common that takes both, can be taking both positive and negative. For you to determine if it's a syncing or a sourcing, it's up to you. But some, they come fixed DC sync, DC source. Okay, so I'm sure that's all about syncing and sourcing. If this was very helpful to you, you can just click subscribe, or just click the like button. And if you have any areas, I repeat again, just highlight there. Can you please do a tutorial about this and this and this? Then I can just do it to help you. Okay. Thank you guys. I think that's all. And what we said, the other thing also, the next video I'm going to be doing PNP sensors and NPN sensors and how they are connected to these syncing and sourcing input cards. Because if you don't understand the syncing, you cannot order the type I sensor. If you don't understand the PNP and NPN sensor, you cannot buy the right module card. They work hand in hand, and you don't need anything in between like a direct contact with a relay. Because sometimes you need high-speed pulses, they must come is there and straight to the PLC. I'm going to explain that in this video. So please subscribe, thank you guys. Okay.